Chapter 5, Section 3, Properties of Logarithms. First, we're going to look at the change of base formula. Since many calculators will only calculate natural logs or common logs, we have a formula that lets us convert a logarithm of one base to another for easier calculation. That formula is that the log base a of x equals the log base b of x over the log base b of a. Base b is the old base, the one you want to change from, and base a is the one you want to change it to. Newer calculators will have a log-based function found in the math menu that will calculate logs. However, I still want to see that you can set up this change of base formula, because there will be those of you that need it, or you may get stuck having to do these without your graphing calculator. And while most calculators do have the ability to do natural log or common log, it's really only the graphing and the fancier calculators that can do other logs as well. This is also going to be helpful for graphing. So this is a really good skill to learn. It's not that difficult. What I tell people is look at it this way. It's log base a of x. The base goes in the basement. So you're going to write log base b over log base b. That's your new base. The old base is going to go in the basement in the bottom. And then the x is going to go, the argument is going to go on the top. Now we've got some properties. First of all, the product property says that the log or natural log of two numbers multiplied together is the same as the log of each of those added together. And these are following along with our exponential properties. If you think about it, what do you do when you multiply variables? What do you do with their powers? You add them. Well, this is the same property, because remember, the answer to a logarithm problem is an exponent. So we're really following exponential properties here. So log base a of uv is the same as the log base a of u plus the log base a of v, and it works for natural log as well. Our quotient rule is what we would expect. It's similar, but instead of adding, we're subtracting. And then we have a power rule that says if you're taking the log of something with a power, that power can come down front. And again, it's kind of following the exponential rules. What do you do when you raise a power to a power? Well, you multiply them. So this comes down front and gets multiplied. Now you're going to need to be able to use these backwards and forwards. In other words, you're going to need to be able to take something that's compressed and separate it into addition, subtraction, and multiplication. You're also going to need to take stuff that's already pulled apart and push it back together. So you need to have a good handle on working both sides of these equations. Okay? These are used to expand or compress logarithms. I'm going to write these logarithms as a ratio of common logarithms and natural logs. In other words, we're going to do a change of base on log base 5 is 16, and we're going to write it as a common log and as a natural log. Then you're going to evaluate the one log base 9 of 0.1 using the change of base formula. So change the base and then give me an answer for it. Pause the recording, try these out, and resume to check your answer. Okay, so as common log, we have log 15 over log 5, or as natural log is 16 over natural log of 5. And log base 9 of 0.1 becomes log of 0.1 over log of 9, or natural log, and that gives you negative 1.048. Okay, now we're going to rewrite and simplify this. We're going to use the product rule and the power rule. Take this one step at a time, pause the recording, give it a try, and resume to check your answer. Okay, so we can separate them into natural log of 5 plus the natural log of e to the 6th. Natural log of e to the 6th, we'll use our rule that says the natural log and e cancel each other out, so we're just left with 6. So our final answer is 6 plus the natural log of 5. Find the exact value without using a calculator. So again, we're going to use our properties here. We're going to bring powers down front. We're going to rewrite and come up with a final answer. Pause the recording, give it a try, and resume to check your answer. Okay, so a fourth root is a 1/4 power, which can come down front. That leaves us with log base 2 of 8. Well, 8 is 2 to the 3rd. They kind of did this the long way around. At this point, I would have just said, well, log base 2 of 8 is 3, and 1/4 times 3 is 3/4. But doing it a little longer way around, 8 is 2 to the third. So again, the power can come down front and give you 3/4 log base 2 of 2, which is 1, and it gives you 3/4. The second one cannot be done because you can't raise 2 to a power and get -2. And then finally, with this last one, we're going to reverse our rule. They're split apart by addition. We're going to mush them together. Actually, no, we're not. Sorry. You could do that. You could put them together with multiplication first and get e to the 7th, and then the natural log and e cancel. Or you can do what they did here, which is they go ahead and cancel and have 2 plus 5 is 7. So either way will work for that. Expand these expressions using our rules. Pause the recording, give it a try, and resume to check your answer. Okay, the natural log of 4x becomes the natural log of 4 plus the natural log of x. The natural log of the square root of z, remember square root is a 1/2 power, so the power comes down front and we have 1/2 natural log of z. This last one is a little more involved. You need to split apart the multiplication first, and then you need to bring the power down front. So we have the natural log of z plus 2 times the natural log of z minus 1. You cannot split up the z minus 1. Remember, we can only split up things that are multiplied, divided, or powers. All right, let's try these. Getting a little more complicated. Pause the recording, give them a try, and resume to check your answer. Okay, so one step at a time, split up the multiplication. And then, so that gives us natural log of x squared plus the natural log of the square root of y over z. Square root is a 1/2 power. That comes down front. So now we have the natural log of x squared plus 1/2 the natural log of y over z. We can split up the y over z through subtraction. So natural log of x squared plus 1/2 natural log of y minus natural log of z. And then finally, the 2 from the x squared comes down front, and they went ahead and distributed the 1/2. In the second problem, again, the first thing we encounter is the 1/4 power. So we take care of that first. Then we split up the x cubed and the x squared plus 3 by addition because they're multiplied. And then we pull the power down front, and that's pretty much it. And then they distributed the 1/4. Okay, now you're going to approximate the logarithm using the properties. They're telling you that the log base b of 2 is 0.3562. Log base b of 3 is 0.5646, and log base b of 5 is 0.8271. So what you need to do is you need to write the numbers as a product or quotient or power using 2, 3, and 5. The power can be anything, but the argument itself needs to be a 2, a 3, or a 5. Pause the recording, give it a try, resume to check your answer. I'll give you a hint. If you're having problems with this, 10 you're going to write as 2 times 5, and 45 is 9 times 5, which is 3 squared times 5. If you needed a push and now you need to pause to try it out, then go ahead and pause, and if not, keep playing and we'll go over the answer. Okay, so the log of 10, that should be 2 times 5. It looks like 2.5, but it's supposed to be 2 times 5. Split up the multiplication, log base b of 2 plus log base b of 5, and then substitute in the values. For 45, like I said, that's 9 times 5. So you have log of 9 plus log of 5. 9 is 3 squared. The 2 comes down front, and then we substitute our values in. Opposite way, and we're going to smush these together. We were expanding, now we're going to push them back together again. So reverse the rules and condense them. Pause the recording, give it a try, and resume to check your answer. So first thing we do is take care of the powers, and they're going to go back on the x and the y. And then we've got 2 logs added, so we will smush them together with multiplication and get log base 2 of x squared y to the 4th. For the second one, again, take care of the powers first, then the division, and then the multiplication. Okay, same thing here. Start on the inside and work your way out. Pause the recording, give it a try, and resume to check your answer. So the square, the power is first. We put the square out. And then we combine the multiplication. And then the division. And now once everything inside the parentheses has been smushed together, then we write the 1/3 as a power, which you can reuse the 1/3 power, or here they put it all under a cube root. Okay, let's try one more. Again, with the parentheses, you're going to want to take care of what's in the brackets, then the 1/3 power, and then the division. Pause and give this a try and resume to check your answer. Okay, so the first thing we did was we took care of the square power and put it where it belonged. Then we combined the addition with multiplication. Then we put in the power, the 1/3 power, which is a root, cube root, and then the division.